Hi, this is Dr. Cliff Cronseth coming to you with another Cliff's Riffs. Today we're going to be talking about diagnostic imaging. I've been out of the loop for a few weeks, and so I'm a little rusty with the technology here. I did not have a chance to make some of my fancy AI slides, but I'll quickly go over some of the types of diagnostic imaging that are out there that may explain some of the nuances of when and why you use radiology. So there's different types of modalities. There's X-ray, which is equal to CAT scans or CT scans. CT scans are simply stacked layers of X-ray that go up through the bones. You can see X-rays typically when you've got this gray, black and white kind of image that goes through the body. The X-rays are absorbed by different density tissues, especially bones, and the X-rays pass through the soft tissues. So you don't see the soft tissues very well. You don't see the MRI quality imaging of the nerves, etc. If you look at the MRIs, however, you can see that there are very fine nuances, that you can see the fluid within structures. You can see very fine soft tissue like nerves, etc. And so an MRI is a little bit more detailed for the soft stuff, and the CT scans and the X-rays are a little bit more focused for bony configuration or calcium deposits. So the key is that the CT scan or the X-rays have radiation associated with it, and the MRI is purely magnets. It's a magnetic field that is generated inside those claustrophobic-like tubes, and those then will create a certain type of setting within the body tissue for the MRIs, and when they release their energy, the MRI machine records those little electronic pulses. But the MRIs are considered not dangerous because it's really just magnets, unlike the CT scans, which is equivalent to multiple X-rays. And then the X-rays are fairly low radiation exposure. The other modalities you have include ultrasound, which is simply sound waves that go into the body and reflect back, showing different layers. Just like you'd see a geologic seismograph or some kind of cross-section of a geology structure, you see layers that are reflected back up to the probe, and it shows the layers of the skin. The other modalities we have are bone scans, and those are radiology tracers or bone tracers that are injected into your body, and those little tracers, those radioactive tracers, will seek out actively metabolized bone, and kind of like a heat map in your house will show up as a bright blurry image. The DEXA scan is used for osteoporosis, and that is really an X-ray beam that they shoot through the bones, the femoral neck, the spine, the wrist bones, and how much radiation is absorbed by those bones will determine how dense the bone tissue is. Another radiology tool is the PET scan, sometimes used for cancer, and that's a little bit like a bone scan that we just talked about, where they inject radioactive material that goes to bone. A PET scan is radioactive material that, or honing material that goes to actively metabolizing soft tissue, especially sugar, because the PET scan uses this tracer of sugar, and cancer typically will be hypermetabolic. It uses up a lot of sugar, takes a lot of juice to keep the cancer alive, and that differential eating up of the sugar and attraction of the sugar will cause the PET scan to light up areas that may have hypermetabolic tissue going on, usually cancer. The so those are the main diagnostic radiology tools that we have. I will go into a little bit more detail next week for those that are watching, but this was really just a test run to see if I can get this out. Anyway, I hope that was helpful for you. We will set up a better scheduled demonstration of the